Welcome back. So I probably should have titled this section of today's lesson Behaviors of a Unique Pointer because we're going to briefly go through a subset of the total available behaviors available to you in a standard library unique pointer. I was planning on building this up, so I was going to say similar to our vector implementation, we are going to consider how we could implement a naive unique pointer. It will not have all the bells and whistles of a standard library unique pointer. What we're presenting here are going to be behaviors, and you can look these up, but behaviors that all unique pointer objects can do. However, there's more in addition to this that we're kind of ignoring to keep this focused and to the point and simple. A unique pointer is going to have a parameterized constructor, which will be able to create a unique pointer to the past resource. There's also going to be a destructor for unique pointer, which is defined to release the resource that was held by it. There's also a move assignment operator defined, as well as, I believe, a move constructor, which will allow us to transfer the ownership of a resource to another unique pointer object. Now here's a couple of modifiers to the unique pointer objects, behaviors that we can invoke on them. One is going to be release, which will release the ownership of the resource to the caller. So if you would like a unique pointer to no longer manage the memory of some sort of dynamically allocated object or some other resource, we can go ahead and call release on that pointer. And what it's going to do is disassociate that resource with the unique pointer. So the unique pointer will no longer manage its memory, and it will return to the caller the address to that object. And now you will be responsible for managing that managing that resource. There's an additional modifier, reset, which releases the ownership of the resource owned and takes ownership of the object whose address is passed to it. So what this does is it releases the resource that was once owned. So we'll go ahead and free it. So this will actually free, and then it will go ahead and associate that unique pointer with a new resource to manage. Then there's swap, which you can go ahead and say some sort of unique pointer object dot swap. Another unique pointer object is the argument to swap, and it will essentially swap the ownership of the two resources such that object A now owns the resource of object B and object B that of resource A. And the last couple of behaviors of the unique pointer type that we'll consider is going to be get, which will provide us with a raw pointer to the owned resource, which could be beneficial to do something like we did in our linked list, maybe to set up some of the raw pointers that were configured to provide that bi-directional behavior in the doubly linked list, as well as quick access to the tail. Maybe for a singly linked list, go ahead and get a raw pointer to the tail so that we could set that raw pointer in our singly linked list data member appropriately. There's also going to be kind of this Boolean operator, which will check whether the unique pointer owns a resource, that is, whether or not what it's pointing to is the null pointer or some sort of data. There is the dereference operator as defined in the manner in which one would expect, which is going to go ahead and return to you the resource owned by that unique pointer. And then finally, there is also subscripting, which will provide indexed access to the resource, provided it is an array owned by the unique pointer. So with that, that concludes our lesson for today. I hope this was clear. I hope you learned something. I hope you can see some utility of the standard template library unique pointer type.